So again, welcome to our class today on our Thursday webinar relating to the inspecting for thermal envelope compliance. Uh, I'm going to throw it in the chat one more time for those who are just joining in and might want to have a copy of the handout while we go through it. It's there for you in the chat. You will get a copy of it at the end after when we send out the certificates as well. So this program, as for those who may not know or maybe joining us for the first time, is the Minnesota Energy Code Support Program is designed to support and educate and empower you as building professionals to construct in the construction of energy efficient buildings. So again, we're not pushing anything that's not required by the code. And so we're really trying to do that baseline conversation. Again, our information is available to you free and online. You can go to our website, check out our different technical documents, resources, look at our upcoming training, both virtual and in person. And then again, if you want to connect with us, ask information through our code here, our code support helpline, our website, minnesotaenergycodesupport.org. I'm trying as best as I can to remember to get that out there. Some of the things you'll find are going to be, again, different training resources, different newsletters that we're putting together to support the building department. One thing that's probably coming out, I hope to finish it this week, is going to be our energy inspection guide specific to the commercial energy code. That's going to include a very simple checklist. I'm talking with some production menu publishers to maybe get us a little handheld item that we can get to everybody as well, but we'll be talking about that here in a couple weeks. But again, this might be finished here yet this week. I just got to go through and do some double checking. That'll include basically some references on maybe what to look for compliance checklists, and then breaking down the different functions, different components of what we'll basically be talking about today, and then kind of giving you some ideas on what to look for. Just that quick cheat sheet for both inspectors and installers to better ensure compliant inspections, right? We all want the same thing. And so that's how it's one of those resources we're hoping will be helpful for you. What I'm now doing is going through and double checking all of my code references to make sure that I've got them all properly cited, which is the harder part. So one of the things that we've talked about now, again, all these resources are free. These will be downloadable PDFs for you. Hopefully, like I said, very soon. I'm trying to get it done this afternoon. But one of the things that when we talk about it, if you've attended any of my classes, you know that I am all about when you understand the why, then you figure out the how. And we go over this every week just to reinforce in our head that the reason we have a building code is to provide basic uniform expectations on how buildings should be built. And the energy code is there to support that in mitigating heat loss and climate energy efficiency, energy conservation measures within the building, right? That's what the code is really trying to drive towards. That not only do we have a safe building, but we have a building that's going to operate effectively and as designed moving into the future, right? That it's a controllable building. Because remember, the essence of code is control how things flow, I use this example, you've probably heard it more times than you want to hear. Control how load transfers across the building, control how energy is used and consumed to heat and cool a building. So again, these are considerations that we think about in the energy code. The energy code, as we know, applies to a variety of different types of buildings, right? New buildings, new portions of the buildings, new systems and equipment. When we add a new service, when we maybe not add a service, add new HVAC equipment. If we expand, we replace, we alter. Depending on what we're doing, there are times when all of these components come into place. And when it comes to the inspection process, it's really about looking at our four pillars, right? The envelope, the mechanical, the service water, and our power and lighting. And today we're going to focus more specifically on that building thermal envelope. Now we understand the building thermal envelope is a key component, a major component. It's to use our physiology class from high school, from biology. It's the skin that holds the building together, right? And so we want to make sure that everything stays within the skin. That's one of those things that, we talk, okay, we're gonna get real medical now. When we watch a football game and somebody gets a hurt, they break a bone, and it punctures the skin, right? We have a compound fracture. That's when we got a problem, right? It's already bad enough when you break or sprain or tear something, but when it punctures the skin, then we've got a whole new ball of wax to deal with, right? We talk about it. We're not going to get into medical, right? Same concept with the building thermal envelope. This is that isolation between the exterior environment and the interior controlled or conditioned spaces. And so that's why it's critical that when we think about how it's designed, the materials that go into it, it is really the first step. It's also become incumbent upon us to ensure that we inspect it for that compliance. Remember, as inspectors, our goal is to ensure that buildings are built the way they're designed. One of the things that always drove me crazy growing up in this industry was once in a while we have a design that wasn't being followed, right? And it took me some years and some experience and some growing to better my ability to stand up to a contractor and say, no, this is the approved design. This is how it needs to be built. I understand you might want to do it different. Then go through the process. I'm not going to argue with you about whether or not it's the same, structural capacity. The reality is this is what was, spec. This is what was designed. We need to figure out, call the engineer, figure something out. Let's get to the architect out here. Well, engineer. Let's get the engineer out here to figure out if this is really what will work. I appreciate your experience, but I'm not taking your word for anything. It's not personal. It's business. And I'm the one who has to stand on the eventually I'll be the one on the courtroom explaining that why I thought that we could change what was already approved by the engineer. So again, I'm all about the inspection process and following what the code, what the plans say. And part of that is understanding what information from an energy codes perspective should be on those plans. Now, again, we'll do some examples here, like we're going to do next at our next class on mechanical systems, looking at the actual plan review process. But from an inspections process or lens, one of the things that's required by the code is that compliance path. This is that designation, right? We see it's listed there in 4.2.511, where we've got, let me get my laser pointer, right? We've got prescriptive. I mean, one of the things that I think is great was when we made this adoption, we included the terms. Not only tell me what compliance path, but give me the terms so that we can better understand what's going on. Prescriptive, energy cost budget, or normative appendix G. What we know them as in our vernacular is going to be the prescriptive, the energy cost, and the performance rating. Now that means that we're either kind of prescriptive means we're following the code. Tell me what the code says. I'm going to follow the tables to their natural progression, right? I'm going to look at the wall system, compare it to the tables. Now, what we know is in reality, there are two ways to comply with prescriptive, right? There's follow the tables directly. Every material, every assembly in that building thermal envelope has to match either the R value or the U factor. The secondary alternative is a area weighted U value, right? That's when we look at a com check, which is why we're going to talk about com check. Com check is part of that prescriptive process. It's telling me now I've done all the math for all the exterior wall components, averaged them all, and I still show that I'm compliant with the intent, with the overall calculated weighted average for these materials, right? So you can get, you have a different levels. I'm starting to get a little bit of a draw there. Different levels of compliance, different levels of flexibility, depending on which of those two paths we choose, whether we're following strictly, I just want R38 in that floor system, right? Or I'm allowing for a 22 and a 9, right? I start to allow for that flexibility, greater degrees of it, depending on what I'm doing. That's why it's critical to understand the compliance path. That compliance path is going to tell me as an inspector what level of flexibility we were allowing in this design. Now, hopefully the plans examiner has also done this review and they have determined that the values are appropriate. And so I'm really checking off those boxes when I go out. The plan saying you need an R30 in the wall and an R10 here, then that's what I'm looking for, right? But if for some reason we don't have that, or when we see those changes, we can draw back to what was the compliance path. And is it flexible in what it's providing or how we reach compliance? The second is that energy cost budget. Remember, energy cost budget is all about how we calculate that annual energy, and it does not exceed the annual energy of a simulated design, right? So in this scenario, we're going to allow you even a greater degree of flexibility because we're looking at how much does it cost to run this house. I see a lot of this. This comes up a lot in historic buildings, right? We don't want to address or manipulate change. I have a project we were recently working on where it's a 3 wide brick building, and so they didn't want to install new insulation. They couldn't remove the brick. They couldn't install. And so they said, we'll take other advantages of other energy savings equipment, and we'll use those values to get to a calculated cost for the year. What that means is we're looking at how does this building going to compare to a design. Now the question I always get is, well, where does the design come from? The design comes from the modeling requirements in table 11.5, right? This comes under chapter 11. If we go back a couple slides, right, we see this is under section 11, the energy cost budget. Well, if we go to section 11, it will tell us the budget design, and it will give us all the different values in the software. That's where the software is drawing its information from. It is not, and then it tells us that this has to actually show us the components shall be modeled as shown on the architectural drawings. This is one of those reasons why we sometimes have to compare, right? What is and again, this is not to be a slight towards anyone, but once in a while people make mistakes or maybe upload the wrong version to the plans. And so you'll have times when maybe a model was created and it doesn't correlate or jive. I like the term jive, but I try to find a more technical term. Doesn't always jive with what's on the plans, right? The model may show that we're supposed to have an R19 in the wall, but the plans show an R15 or an R27, right? Whatever it might be. And so it really becomes that, is this plan consistent with what I see in the field and on the drawings? So again, understanding that if there's the compliance path, there's going to be a software that runs that calculates the annual average daily heating, cooling costs. It's be based on the number of people. All these different components come into the reality of this building's design and the simulation program. And and then all of that works out to a dollar value at the end of which is what we're comparing, right? The reference design with the budget, we would call it, and the as design. And as long as it's equal to or less than that number, we're good. And then as the inspector, it's my job to make sure everything that's on that report, anything that's on that plan is in the field, or else there's the potential that we're not going to have the level of compliance needed at the end when they supply this final report. That third alternative in that compliance path is going to be our performance rating, which is again using some system like a USGBC, GBCI, some system that's going to rate the performance, not necessarily a dollar for dollar cost calculation, but a different rating process. And again, it follows the same thing we find in Appendix G. We're going to find that table that tells us what's the expectations for the design, for the model, how do we calculate all these different components for the baseline building. All of that's in there. And really what we're looking for is, does the building, as an inspector, is everything that's on this plan in this building, right? Everything has to match in order for this building to come out with a rating or the energy cost calculation that we're looking for. So that's really the essence of what we're talking about when we think about these commercial compliance paths and how they affect me as an inspector doing my inspection out in the field. Now, again, we talked about this in the context of the prescriptive compliance path, right? When we look at prescriptive, which is section 5 of the Energy Code, we're looking for all compliance paths shall comply with these particular items, which include things like submittals, mandatory requirements, testing, those kinds of things. And then in addition, for those that are complying with section 5 alone, which is going to be, again, our prescriptive compliance path, then they're going to either choose the fenestration, the values that we find in the table, or they're going to do that trade-off compliance COM check, right? So follow the tables, or do the com check, right? So again, if we look at another graphical representation reminder, if it's everything, all the things that are not shaded have to be complied with regardless of the compliance path within this section on chapter 5, which is on the building envelope, where then we'll choose between, based on our compliance path, are we following 5.5 or 5.6 in those tables. 5.6 again is com check. And again, it's going to give us a series of reports. One of the things that, again, we have to double check is just because we see the green line doesn't mean that our building is compliant. We need to verify that the values we see in each of those sections is what's on the drawing and it's what's in the building. And then ComCheck will give us some other things. We'll talk about ComCheck here in a couple weeks, but it'll give us some values on, maybe our mechanical compliance, our lighting systems. And again, we're not just taking the word, this is one of those trust but verify kind of moments when we're actually going to be walking through and verifying that everything that's identified in these different systems is in the building or is on the plans. So again, what else is expected of us, of the design, is to provide us with these insulation values, the fenestration, the duct systems, the air barrier location. So when we're thinking about how we're going to inspect that, I usually think of it in 4 different ways, right? What's the location of the envelope, right? Because we understand that a building is going to be made up of multiple different components, especially when we think about it from an ASHRAE-based perspective, because ASHRAE allows us this concept of the semi-heated area, right? Now, if we have unconditioned spaces, those have to be approved by the building official. But again, if I'm going and doing my inspection, I need to understand where is the line and what am I looking at? Am I looking at just the exterior wall, or is there a separation that exists between a ventilated and an unventilated space, right? So in this scenario, I would be looking at this wall. The end of my inspection is not the full exterior. I'm going to be looking at all these different elements of the building, right? And again, we have non-residential, residential, semi-heated. The code, whether we're looking at it from prescriptive or one of the other compliance paths, remember this is one of those sections that all compliance paths have to comply with, is labeling, clearly indicating on the plans these space conditioning areas, right? If we don't have the proper information, we can't do a proper inspection. And so I might go walking around thinking that everything in the building, if I'm just doing, and I follow this exterior line, and then I realize that I would not necessarily realize every time that this is a semi-heated space that we're seeing in this little delivery corridor, right? And in the end, maybe this is a conversation that we end up having that says, well, just make this a conditioned space and then leave it alone, right? It makes it simpler. But again, sometimes that's not the design. I've done some, and again, I know we're talking commercial, but I've done some residential where they've wanted, and especially in some of us have seen these in different commercial applications, where we'll maybe have an exterior wall and then we'll have a corridor space and then the interior occupied spaces. And so that corridor is semi-heated. It's not part of the conditioned space. It's really those office spaces that come off of it. And so then that's where my thermal envelope needs to be evaluated. Knowing that makes it easier for me to make sure my inspections are all accurate. Again, I never like to be the one that gets called in. Those of you that maybe I've already told this to, I worked for a judicial system. I was a judicial inspector for the court system. And so we had to have conversations with builders and inspectors and say, hey, so what did you actually inspect? Is this part of the building or is this not part of the building? Where did you inspect? And it really does turn into a long conversation. And it really is frustrating sometimes for building inspectors when it's, well, I inspected what I thought. Well, what you thought was not what was on the plans. And so that's why we need to have this drawn or designated on the plans. Because again, looking at this building, we may think that's the building's envelope, but in reality, this is the envelope that we're looking for. Because while most of us would probably say, well, this is the structural components, and this is where I'm going this is where the insulation would have been installed. What we realize is these are multifamily units. This is a multifamily structure, and they have thermal separation between floors because these are individual units, and there's no reason If this unit is vacant, this unit does not heat the area surrounding them, right? And again, if it's office space, it's the same kind of principle. The tenants aren't wanting to heat the surrounding areas. And so they want to heat their unit specifically, and they want to control that as much as possible. I was in a building over in I think it was in Denver, in the 15th floor. And again, it was one of those, we control this space. The whole rest of the building, we don't care about. We want to make sure we know the temperature, and we're only billed for the energy costs associated with our section of the building. So location, critical to understand. Again, make sure it's drawn on there. If it's going to be the corridor, or if we're going to decide to change it later, that way we know exactly how it shows up. And that way I know what I'm looking at when I go out as an inspector. Where's the roof line? Am I looking at the lower end, the bottom end of the steel framing, or am I looking at the top of the framing, right? A lot of times, and we'll talk about this, this is the perfect, in my opinion, perfect segue into the next component we're looking for as an inspector, which is the material, right? If I'm looking for insulating material here, sometime I'm going to find fireproofing as well, right? So making sure that one material can perform multiple functions if it's installed properly. I walk around MSP the other day looking up as they're doing some of their remodeling, and I'm checking the fire foam, and then I'm thinking, and then I pull out, because I'm crazy, so I pull out my thermal camera and I start looking up, and again, you're seeing it perform not only the function of fire separation, fire control, but it's also controlling air movement because it's installed to the appropriate thickness. So again, knowing the materials, knowing the design, almost like, I don't think I have a picture in here of it, but it's just like, G.I. Joe used to say, knowing is half the battle. And so knowing, am I looking at the R value or the U factor on the material, is really going to be that critical to understanding how are each of these components going to be impacted by that, right? Where am I located? Am I in climate zone 6 or climate zone 7, right? That's going to tell me which table to look at. And then I can look at whether I'm looking for the maximum U factor, C factor, F factor, or if I'm looking for that minimum R value, right? What am I expecting to see? And again, hopefully we've got this done at the plan review side, but if not, we have that conversation out in the field. I usually find that it's on the plans, and then when I'm out in the field, that's when I start talking to contractors, and they're like, well, I can just do this. No, see, this is the minimum number, not a suggested number, right? And so that's when we start having those conversations. Regretfully, for those of us that have done inspections long enough, and maybe it's just me because of where I live, in a rural part of my state, I spend more time educating my first couple inspections with a new contractor or a different contractor. I spend time educating them more about what how the code is intended than actually doing my inspection. I could be in and out in 15 minutes, but I spend half an hour explaining why these things are important, so that I don't have to have that conversation again at the next home, right? But what we're going to be inspecting as part of this process, and part of those tables, are all of these different components we see here, right? From the roofs to the walls to the floors, whether they're vertical or horizontal separations, that's where we're looking for that thermal control, right? Thermal envelope control, it's going to be horizontal, vertical. And so where are we going to find those components? Remember, not all insulation is created equal. Just because it's insulated doesn't mean it's appropriate for that either application, or again, depending on the design, it might not be appropriate for the way the design was laid out. And so again, we're going back to what was the inspection expectations, and that's where our little technical guide will help out, hand that out to the contractor and say, look, just because your method of installation, you're still using insulation, your method of installation changes certain factors. I was at a project the other day, and they were applying some spray foam. And so I was just, I'm nosy. So I started asking the spray foam applicator. I said, so what do you normally do when you prep? It's a very hot, humid day. I know the moisture and so we had this whole long conversation about, one of the things they do as installers before they come in is they check the moisture level of the substrate, because it will affect how it adheres to that sheathing. And so we had a great conversation. Some things we don't think about in different methods of installation. And that's why the code specifically requires in the mandatory provisions that we think about product installation requirements. And that's where we're going to find a lot of the things that maybe we need to refresh contractors on is going to be in that section 5.8. Because and remember, when we think about insulation, R values and U factors are those methodologies of calculating how energy is either resisted or transmitted through a material. But insulation is just one piece of the puzzle, right? The air barrier is part of that conversation because insulation doesn't restrict heat transfer, but it doesn't resist air flow, right? Air will still permeate through most types of traditional insulation, right? It's our insulated jacket we talk about all the time. Our insulated jacket will allow heat and air to move in and out slowly, but we still get air movement versus our air jacket, our windbreaker. Our windbreaker is designed to stop the wind completely, right? It's designed of a different material. And so when we think about how our insulation is installed and the different types of insulation that we might be utilizing will give us different expectations on both insulating capacity and air leakage, air impermeability, right? So again, making sure we don't just accept that. And again, we have this conversation as plans examiners and those of us that do inspections. Those materials are not always the same. I can't replace fiber if it calls for fiberglass insulation and I replace it with a different material. It may, just because it may have the same R value doesn't always mean it performs exactly the same, right? If I'm calling for spray foam because I'm using it to stop air movement completely, and I replace that with fiberglass insulation, then I'm going to have air movement that wasn't part of the original design. And so again, that's why it's important to understand these concepts and important for us to, at all levels of this process, have these conversations about what's being done and why. The why is really critical in this instance, because as an inspector, I'm more interested in how it's being installed, right? The level of competency or the level of workmanship at which it's being installed. And so I should really just be verifying that the plans called for 5 R19 bad insulation. I'm expecting 5 R19 bad insulation. I should not, nothing frustrates us more than when we show up and it says, at least, and maybe this is a small thing, but again, it's indicative of a level of, again, well, I've said this 100 times. I take pride in what I do. I expect things to be done the way they're supposed to be done. If you're not willing to pay attention to the small things, what type of insulation was spec'd and installed and designed, then are you really paying attention to the bigger things? Are we going to have issues of not proper spacing, not proper nailing? This is just an indicator of a larger problem where you can't follow. We're not seeing a project following the approved design. Now, remember, they're calculated 2 different ways. Remember, U factor is the calculation of the entire assembly, and R value is that specific material. U factor is looking at how much loss do we have, and then R value, by doing the opposite, is how much do we resist heat loss, right? So they're either sides of the tug of war, right? One is just the inverse of the other. But U factor, we're not going to have our always famous, which one that came first, the chicken or the egg. We know that the U factor came first 240 years before the R value was created, because the R value was, again, just looking at one particular material versus the entire assembly. And again, when we think, and the math has been done, and then we had this conversation, I think, up in Detroit Lakes a couple weeks ago, about, are we losing something by going with the R value? And the math has been done generally to make sure that you're not, but it is a good thing to think about. I may have to put I may be calling for an R30 when in reality, when I look at the totality of the design, I may only need an R20 in that wall because of the type of exterior siding, the type of exterior cladding, whatever we're talking about. The design, the assembly is actually more effective, right? And so that's one of those things that's really important for us to really think about is how it's calculated. And again, we've gone through, we've demonstrated before, but this is not something that we as inspectors are out there calculating on a regular basis, right? This is something that we should done at the beginning of the process. But again, for us to understand, our value is one material, U factor is the entire assembly. And so if we start adding in, right, we've done this math calculation before. We've seen that at 80% of the wall is going to be cavity and 20% is going to be framing when we do a normal 16 on center. If we start talking about metal framing or maybe different framing patterns, then again, those values change. But if I'm adding in extra insulating board, if I'm adding in DINS glass, if I'm adding in different exterior sidings, exterior cladding, then again, I'm adding value, thermal resistance value that could be incorporated. And that's why it's important to make sure all those components are identified, because slight changes, right? 13 plus, as we see this design, 13 plus 5.7 gives me a U factor of 0.057. U factor of 0.051 is what we're looking for, right? So I am not going to be compliant with the prescriptive requirements of the table. But if I add a little bit extra to that U factor, that insulating cavity space, right? If I go from an R13 to an R17, now I have exceeded the requirements for the U factor, right? I'm still not matching or meeting the requirements of the code, right? Of just the simple R value calculation, but I am getting it from the U factor. And again, if I add in extra spacing, if I add in extra, we'll talk about this in some of those other contexts in future classes, we start adding in, a brick veneer and some DINS glass and some other materials in that process, and we're really going to see those values shift dramatically because it's looking at how does that building work. If you ever have a question on some of those designs, remember at the back of the book, in Appendix A, you'll find a list of pre-calculated assembly U factors and thermal resistance ratings, right? So you can jump in there and you can see some different pre-calculated values for roofs and walls and slabs and those kinds of things, and look at what would a double layer of I think we're looking at metal building roofs, a double layer of insulation look like. And what are the relative R values that come out of it? All that math is pre-calculated. So again, you can look at it, you can educate potentially different contractors on those values. If we look again, just a couple examples to think about, because again, I just want to make sure that you can drive back to the contractor. Look, the code is helping you out. It gives you that value, right? You don't have to go and be a science major in order to go to the back of the book and check where it's already been pre-calculated, right? And so if I'm doing a 6-inch block on a concrete block wall, and I'm going to have it, let's just say I'm going to have it partially grouted and the cells are going to be insulated, I can see what that U factor is going to be right there on a 6-inch block, right? And the table continues to go on. I'm just not going to list it all. But again, these tables, these pre-calculated values exist for the different assemblies that we find located in the code. Now let's talk a little bit about each one of these systems specifically. As an inspector, what am I thinking about as an inspector? Remember the state in its adoption of the code modified and required that we go from an R5 to an R10 in the roof insulation associated with our curbs, right? And so mechanical curbs, it's not just skylights, it's now mechanical curbs, roof curbs, and they have to go to the R10. Again, and if they're installing new rooftop units, there's the correlating section in 6.11 that tells us that if we're adding or replacing new equipment, then we have to think about not only the curb, but also the height of the curb to compensate for potential re-roofing that may come later, right? So we want to make sure that roof system, as we think about existing buildings being retrofitted, we want them to have what the code is expecting when it comes to insulation above that deck, right? And so again, pre-calculating, thinking ahead, saying, okay, If I'm going, and again, we can understand it. We can argue about it. That's a whole other conversation. But more importantly, we can understand that if I'm replacing the rooftop unit today and I'm replacing the roof in 2 years, then I might as well calculate what would be the minimum R value to replace that roof system, not go with, well, I replaced this, now I don't have to touch it, because I don't want to interfere with my existing equipment, right? We want to think, that's where the state's kind of said, nope, think about it beforehand. Make sure that everything around that area of influence is going to be improved to allow for future code compliance, right? That's the expectation. We are thinking not just about how the building is built today, how is that building going to perform for the rest of its useful life? And so as we think about things being replaced, that's going to be impacts that'll be brought into the concepts. So again, one of those things that, again, I've really been really focusing in on the use of technology. Maybe it's a little bit too much, but I've been really focusing on the use of technology to assist in educating my contractors and contractors I work with on code compliance. And I think this is one of those great resources. I've shown you guys the tool that I've used before. If I haven't, I will show you now. If I can get it quickly. Give me 2 seconds. Okay, I'm back. I've been carrying this thing around for months now. I love it. So this is a thermal camera. You can barely see it. That attaches to my iPhone, right? It was a $200 expense, and it allows me to take all these pictures that we see on the screens, right? Where I go out and I'll do this inspection, I can use a high-end thermal gun, which can run you thousands of dollars if you want the good ones. Or you can use a very simple device that hooks in with my phone. I can carry that around, pop it in, take a picture, done. Show the contractor, look, here's where I'm seeing thermal loss associated with bad insulation or bad thermal bridging that may have taken place, right? So when you look at different roof structures, you can start to see how are they being impacted by design. Now, we know that in metal buildings specifically, we're required to have that thermal spacer, right? We're supposed to have that secondary layer of insulation. And in this situation, they didn't have it, those thermal breaks, that thermal bridging done properly. And so you see that relationship between the insulated value, the heat that we're getting from the insulated areas, insulated portion, and what we're getting from the actual steel frame itself, right? That's about a 15-degree difference in what we were seeing. And so remember, if we're talking about the installation of these types of materials, section 5.9.33 tells us that we need to make sure that we're installing them to the manufacturer specifications, that we're thinking about how they're installed. And that again, the code tells us in table 5.5 tells us that we're not only looking at the minimum R value for an R25, but we have that R11 liner system. Remember, we want to make sure that we incorporate both. I've seen way too many designs that just say, we're going with R25, we're good. No, it says plus, which means you have to do both, right? And so we want that liner to make sure that we're going to have that proper thermal break so that we're not losing heat through that system, just like or creating additional requirements for heating, because that beam is going to let off a lot of heat. I mean, that's an extra 7 to 15 degrees, depending on where we were in that building. And so that's going to heat that space, and it's going to be requiring more cooling to compensate for that conductive energy, conductive heat. Remember, location. Remember that the insulation that we talk about in our building, this is why it's important we identify the where, right? And that, remember that first picture we showed was at the roof line, not in the suspended ceiling section, because roof insulation cannot be part of a suspended ceiling, because this is not for it's removable, right? I've been in places where they've taken them out, moved them, done whatever. So again, this is more for that sound attenuation. So, and that's where it's important for us to understand how that system is being designed. What we're talking about when we think about ridges, not rigid joints in that rigid insulation, right? When we're thinking about one of the conversations we had is, what does the code mean by the term staggered? That's a great conversation. That's a great question. And the code doesn't define what staggering is, except to say, go back to the manufacturer's installation expectations. And so maybe that manufacturer has said, we expect a certain level of overlap, a certain expectation. Is it, in this kind of scenario we see here where they've got double layers and then they're stacking or staggering against the other components. Again, so it's one of those conversations where we're really doing that inspection and we're thinking, how is this going to, again, ensure that the building doesn't have thermal heat loss, right? Air is not smart. Air moves and is not going to say, hey, it wasn't expected to be there, so let's move around. One of the things I've seen a lot of installations, and one of the realities is when we talk about this, when we talk about normal inspections or integrating in our energy inspections with normal work, when I'm doing a roof installation, I always double check what material we're using. Now, you can't build the same. We have a lot of times we think this is the way I've always built it. We'll build it this way still. And then in reality, we don't have that ability because, again, new materials have new expectations for installation. I need to go faster because I'm going to run out of time. Same thing we think about above grade walls, right? We understand the tables, what the tables tell us. We understand that when we're talking about those different installations, again, we're thinking about where's my example? Where we're, again, above grade walls, the definitions exist here of what is an above grade wall, what is a below grade wall, a steel frame, and those types of examples. When we think about how are those components actually installed, we want to make sure not only are we thinking about how are we thinking about the wood framing, but then also points of condensation and contact between plumbing fixtures. And so again, this is one of those opportunities for us to kind of see in reality that we can do multiple inspections at once, multiple corrective violations, corrective notices at once. Again, if we're looking at the installation, we want to make sure it's complete. The code tells us that we need to expect that the installation of these materials is going to be consistent and it's going to be completely, it's going to have substantial contact with substantial contact in all 6 sides. And so having these gaps will allow us to have spaces in our design where we're going to see some changes in temperature because they're going to have those gaps. Same concept here. You can see the uniformity in which it was installed versus the previous picture where we had a little bit more of that spacing going on. And so these are going to be places where air and thermal and heat is going to immediately gravitate towards and use to get out of our buildings. Right? The code requires, if we go back to 5.8, that installation expectations tells us it needs to be labeled. It needs to be documented, especially if we're doing some type of a blow or some type of some type of installation that requires specific thicknesses in order to capture that value. So again, it has to be documented what that blown insulation value is going to be. It also requires that we think about how they're compressed. There are tables that address the impact on bad insulations that get compressed and how they're going to resist or provide for that thermal capacity. So again, make sure they're installed properly. One of the things that you'll sometimes hear, especially in inspections, is that grade of installation, grade 1, 2, and 3, perfect. A little bit of problems, and more than a little bit of problem. There is a current move to shift this grading system from properly installed to not properly installed, which will again put a lot of responsibility on us as inspectors to say, what is the expectation when I come? I shouldn't see bunched up, pushed in insulation. Install it right, take pride in what you do, and it'll perform more effectively. Same thing when we talk about loose fill. Again, remember, we're looking at when it can be used, and then again, that certificate telling us what was installed. One of the things we think about is baffles, right? And make sure that they're complete and they fill the space. Not that they were purchased one size, had some extra, and it just didn't fit with their spacing. So we just nailed it in place, right? We see here some stuffed in insulation, again, not performing the level of expectation, right? And so again, what is our expectation? Both of these are going to be no's, right? We want that baffle to completely fill the air. Remember, that baffle is providing controlled ventilation of that space. And then this is not providing any significant or consistent level of thermal protection. So That's where that one's at. Remember, substantial contact, if a design incorporates air spaces, make sure they're provided, make sure they're sealed depending on their design. Some air spaces are open, some are sealed. Again, if it's sealed, you're creating a pocket of stagnant air to resist air transfer. If it's open, there's potential that you're creating a draft to remove moisture condensation. Make sure that you're thinking about it, and make sure that it's properly reflected in the design. Again, below grade walls, remember in the below grade walls, the state modified it so that the insulation is going to be on the exterior side of the wall or integral to the wall. And so again, we're looking for insulation that is on the outside of that wall system, not on the inside. Thank you for putting the R10 in there, but guess what? It's on the wrong side. And then not only, so because we're doing that, we also need to think about, don't do this one, right? Not on the inside, on the outside, or integral part of the system. But also when we think about, because we're moving it to the outside, then we need to think about protections for that insulation so that we don't have unnecessary damage to those spaces, those materials. Floor insulation, same concept. We're trying to maintain that substantial contact. So either it's in substantial contact or we provide a proper continuous thermal envelope, right? So again, if it's in my home or in the building that I live in, this was not possible or was not desirable for the designer, for the installer. And so we went with a gypsum system that said, okay, we're going to drop it down. And so then but it has to extend all the way up. We can't just allow it to stay on that floor, and then this space would be uninsulated. So again, we want to make sure this continuous nature of our thermal envelope. Slab on grade, same concept, right? We want to make sure it's all the way across the system, like we see here in this image. If not, heat is smart enough that it will go with the path of least resistance, and we're going to experience heat loss right through this area. So we want to make sure it's either continual, because you can see the that insulation here, you got some rigid there. That rigid comes in, and so now this is going to be isolated, thermally isolated from the other in conditioned space. Or you might even allow, because this is not necessarily a wall, not a below grade wall, it's a slab, difference there when it comes to the code, but they could install 2 layers of insulation, right? Again, when it comes to the slab, the state didn't modify its expectations, but for below grade walls, it did. So again, if we're looking at it in inspection, where is it going to be installed and how are we protecting it? How are we sealing it to make sure that, again, we have continuity? Remember, part of our wall, part of our thermal envelope incorporates or includes fenestrations and doors. And so the code has a whole list of expectations. Remember, looking at U factor, again, heat loss in that system or that assembly, and also solar heat gain. How much temperature gets added because of that design? So when we're thinking of, typically we may not always think of windows as that part of that building thermal envelope, but as a critical component because again, we're making sure we don't lose heat because of poor sealing around fenestration, but then we're also not gaining heat that's not been incorporated into the design because we've got these huge windows in our front office or our front office space, or in this example, right, this retail space. So we have all these windows and the sun's glowing, is beating down on it, constantly heating these areas, and we're not thinking about that in the calculation of our mechanical systems. And so our mechanical systems either run too much, and then we have to have unnecessary replacements, and we have failures. So again, this is part of that conversation that we have a design, but then as an inspector, I'm verifying that the window that's called for is the window that's on the actual facility. And again, we see this all the time. And one of the things I always always get on my plans examiners, one of the things that we do is internally when I work for my department, the department when I was the manager, was we would sit down with our building inspectors and our plans examiners once every couple of weeks and have a gripe fest, right? What are you not getting in the field? What, or what am I providing that's not being, and so it was a good time of friendship, right? After a while, we got to where it was really without that much. But one of the things we really thought was important was sitting down with my inspectors and saying, okay, what are you guys not getting in the field that the plans examiners can do a better job to assist us in making sure? And one of those was the windows. right? Provide those U factor solar heat gains for every every one of those window schedules, because my inspector didn't have time, doesn't, he's there to do his job. And he's trying to be as effective and efficient as possible in his job duties. And so he doesn't always go and check to make sure that all the values are there. And then more importantly, in this example, I would make sure that those values match, again, we sometimes see this, especially in some of the larger commercial entities, they'll send you a value that matches a code, but it's not matching what's the state's code, right? So we want to make sure this says it meets the 2018 requirements. Great. Good job for you. Does it match the Minnesota Energy Code section 55111 or 41? Verify that the codes are the same so that our inspectors can go out there and do their jobs to inspect for fenestrations and doors, door seals, right? Opaque building envelope tightness requirements. Remember, we're looking for penetrations, for elements that are going to allow us to have, that are going to impact that skin of our building, right? Little lacerations, cuts, and nicks. Guess what? You're going to know when they're bleeding, right? Same thing with the building. We want to make sure that the building's thermal envelope, much like our skin, is as intact as possible. And so that includes looking at things like skylights and roof lights and dynamic glazing potential. So again, if we're having a system that incorporates, not every building has to incorporate it, but when they do, is it incorporated properly? Are we finding it in the right windows? One of the problems I've seen, again, time and time again, maybe I've just, again, where I'm at is, well, they'll order the right windows, they'll just put them in the wrong spaces. And so, they might have a window system that's supposed to be on the south side of the building, but because of mislabeling and the way they were placed around the yard, they end up on the north side. And so, yeah, great. This one's now got way more solar heat gain than it needs, and the other one doesn't. So nothing makes a contractor angrier than knowing that they put the wrong windows in the wrong spot, especially when it's their fault. Remember, some other products that are listed, identified, specified for as part of that building thermal envelope is going to be the recessed equipment and maybe our door seals. Remember, those weather seals around loading docks are critical because, again, these are areas that are going to have potentially large openings that are going to be exposed to the exterior conditions. And if we don't have the proper seals, when that truck backs in, guess what? We're getting nothing but airflow for however long that's going to be there. So either we properly protect it through the thermal envelope, or we isolate it and turn off the heating system in that area, which again is not a beneficial concept for a lot of people. Question is, what's the solution for multifamily buildings with balconies with concrete floors? So one of the things that we talk about when we talk about those door seals, right? Those are considered exits or openings in the building thermal envelope. So they need to make sure they maintain those proper seals. That the concrete deck itself, one of the things I see a lot of is, again, they're going to incorporate fiberglass. One thing I've seen lately is fiberglass mesh inside the actual concrete mix to, again, provide for that thermal bridging. But again, there's a variety of different ways that I've seen it done. But for the most part, you're treating that entire assembly. If they can't maintain the thermal envelope, then they need to provide some level of thermal continuity across the entire system, right? So the envelope is not just the horizontal, it's also vertical. And so you can figure out, if you have a 8-inch, 12-inch, floor system that penetrates through there, then throw in some heating, throw in some other insulating capacities there. Again, I've seen a lot of that, hydronic control or hot water control or heated floor controls, specifically in areas like Minnesota, not necessarily in, but areas like Minnesota, because again, it's one of those realities. You get a lot of cold and you got to protect that floor from being a heat sink in that situation. Very similar to what we see with maybe a door seal. We talk about vestibules. We talk about the role of vestibules, revolving doors. And again, remember, air leakage is a requirement, a fundamental mandatory provision of the code. And so we got to make sure it's installed, and it's part of that conversation when we think about how our system's being installed. So not only am I looking at it from the installation side of it and saying, okay, you put the R21 bad insulation, but it says it's going to have this craft face class 2 vapor retarder. But when I go on site, am I finding it, right? Is this just R21 bad insulation, or does it have the appropriate uh, 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 vapor retarder or air barriers installed in it? You know, am I looking for those things? Again, if it's going to be a sealing issue, if it's going to be a provide caulking along this different seam, then make sure it's specified and make sure that as an inspector, you're verifying it. Again, this is where we have that back and forth between our plans examiners and our inspectors. You call for it, I'm going to inspect it. And then when I get a phone call saying, why didn't it work? Well, I made sure that you identified it, but my inspector didn't check it out, right? Work in that relationship. And, you know, one thing I always do, again, maybe it's just me, I always sit down and look at the plans before I get out of the car one last time. What am I looking for when I'm there? Remember, if we're looking at some of those different trade-off systems, again, we may find things that are identified, and one of those things that I'm seeing more and more as people move towards this performance process is higher expectations of air leakage control versus higher insulation values. And so again, knowing which compliance path they're using is going to make me think, okay, well, they're really hitting this air control really hard. So I'm really going to pay more attention now to the air sealing, the penetrations, and all that than I am always than maybe I would in a normal prescriptive compliance process. And so again, thinking about those things in that situation, because those models should be operated to provide us that information. Now, again, we're not going to go through the ComCheck. We don't have time to go through ComCheck real quick, but again, there's certain things that we're looking for when we think about ComChecks. And one of the things we always have to think about is comparing our ComCheck not to the table, but to the plans, right? To make sure that everything is identified properly. Here's just a couple examples for you, though, if you may want to look at the notes later, where we're looking at the steel wall system. We're comparing it against to make sure that those values match with what's in there, and the air infiltration barrier is listed in that sheet where it's supposed to be in relation to the different materials that are identified. Again, we got air infiltration, we've got rigid that doesn't give me an R value. And again, this is another example where we have a half-inch fiber break, thermal break, again, to provide us that thermal separation. Sometimes you might see that, again, depending on your design, you might see that in those balconies. I don't think I've ever seen it in a balcony, but again, potentially. Another example. Remember, as we finish this up, I want to remind you of our upcoming webinar series. The ones that you see indented with the asterisk or the star are our best practices series. That is a different login than what you use today. The one you use today is for our normal first and third Thursdays. We'll probably be sending out a survey, a specific survey here in a couple of weeks, asking you about the time, if this 10:30 works, or if there's a better time, 7:45, 7 o'clock, 8 o'clock. We've got to think about all of our different programs, but again, we want to make sure it's reflective of what maybe works for you guys. So again, take time to respond to that. We picked 10:30 because we had only a few responses to our first initial survey, which I know nobody knew who we were, so I take that. But maybe that's, again, something we talk about later. As far as in-person trainings coming up, remember we've got the one on the 28th in Mankato, another training on the 29th. So it's a 2 days. You can pick which one you want to go to. Go to both if you want. In Marshall, the one is going to be on the thermal envelope, what to expect out in the field. Very similar to what we did today, but a lot more pictures and more in-depth conversation. And then the other is going to be more of a look at the thermal envelope and the compliance paths, and more of a deep dive in the compliance paths side of things. Remember, we decided to change it a little bit and put that ComCheck conversation as a 3-hour training, a deep dive walkthrough, take a couple buildings and have questions. So if you have questions, be prepared. Come to that virtual training on the 12th. Again, that you can specifically sign up for that one at the website. Remember, we've changed the website a little bit to make it a little bit easier when you go to the upcoming trainings to see virtual, in person. And then if you want to host a training, would like us to come to your jurisdiction or sit with your contractors, sit with your design professionals, have some one-on-one virtual or in-person training, let us know if you're interested in that kind of thing. Remember, we do have the helpline. If you have any questions, feel free to submit them that way. When you fill out your survey, if you have not already given me your DLI or AIA number for those architects and building officials, put that in your survey. Let us know if there are specific topics that you want. Hope and I are going to be sitting down at the ICC annual business meeting this week, and then in the next couple of weeks, and figuring out what is 2025 training going to look like. So again, give me some ideas of what you think would be helpful. Like I said, we'll try. I'm going to try really hard to get this inspection guide done today, tomorrow, and get it out to you guys so that you guys can have it, use it, and then, like I said, if we can print little books, that would be helpful for you. We're more than welcome to do that. Remember, everything we produce is free and clear for you. So if you want to use it, shift people to it, send people to the webinars, all that's there for you. If you have any questions, feel free to send me an email. If anybody in the St. Paul area is bored tomorrow morning at 8 o'clock and wants to have a little sit-down conversation or chat before I get on the airplane, let me know. Send me a quick email. See if I can't meet up with you and have some coffee, have some breakfast, talk about energy code or code and our different offerings for our group. You guys have a great week. I appreciate you participating and being here. Sorry I didn't have a whole lot of time for questions, but if you do have questions, I'll stay on for a little bit. But otherwise, you guys have a great week, and we will see you again soon.